Today we're on 0-6 if yours got cut off, which I'm sure they all did. Multiplying probabilities. So I think we already kind of talked about it, but independent and dependent. If you're independent, you don't need anybody. If you're dependent, you do, right? So independent is where one does not affect the other one. For example, flipping a coin and rolling a die. Those don't have anything to do with one another, right? If I get tails on the coin, it doesn't mean that I'm going to get a 2 on the die. They don't affect each other. So those are independent. So if it's independent, you say probability of A and B equals probability of A times probability of B. Dependent is where the opposite. One does affect the other one. For example, if I have a bag of marbles and I pull a marble out and I don't put it back, that's called without replacement. I've affected the outcome of the second marble because now I've changed the denominator. I've changed the total of what is possible of happening. Does that make sense? Now, if I pull a marble out of the bag and I do replace it, then it's like the same thing again. Do you get what I'm saying? Okay. So probability of A and B is probability of A times probability of B following A or B given A, depending on how they say it. Conditional probability. If A and B are dependent events, then the conditional probability of B occurring after A has already occurred is probability of A and B over probability of A. Okay, so I'll explain how to use those in a second. Determine whether the events are independent or dependent, then find the probability. You have to do that anyway, or else you don't know what formula to use, okay? So, a red die and a blue die are rolled. What's the probability of getting a 3 on the red and a 5 on the blue? Do those have anything to do with one another or not? They don't affect each other. So is it independent or dependent? Independent. Excuse me. So we're going to use the independent formula. Up here, this first one, we're going to say the probability of the first thing times the probability of the second thing. That's all it's saying. So what is the probability of getting a, what's the first one, a 3? What's the probability of getting a 3 on any die? 1 out of 6 times probability of getting a 5 on any die. 1 out of 6. Multiply, what do you get? 1 out of 36. Do you guys get that? How easy that can be? Okay. The next question, a bag contains 8 blue, 6 red, and 5 green marbles. 3 marbles are drawn one at a time. Find the probability the second marble is green given the first marble is blue and not replaced. We'll do this part second. That's like they're asking part A, it's replaced. Part B, it's not replaced. Those are like two what did I just say? Sorry. Not replaced and then replaced. It's two separate questions is what I'm saying. Okay. So the first question is not replaced. Okay. What is the probability that the first marble is blue? I'm going to start there. I'm going to fill in the first spot. If the first marble is blue, what's the probability that that happens? 8 out of what? 19. Do you guys get that there's 19 marbles? Okay. The probability that the first one was blue, we just said. The probability that the second one is green. Okay, so we did not replace it. But we still have how many green marbles? 5 out of how many now? 18. We took a marble out and didn't put it back, so there's only 18. Do you get what I'm saying? This is somewhat of a conditional probability. What this is saying is, find the probability the second marble is green given the first one is blue. What that means is, this is my answer. I don't actually have to do the math. Here's the difference between this question and the last question. The last question, first of all, used the word and. Do you see that in the top with the independent events, they use the word and, probability A and B? This one didn't use the word and. So this is very, you really have to pay attention to semantics, like the words they use. They said, find the probability this thing happens given this thing happened first. Do you see what I'm saying? That's somewhat conditional probability because it's saying, hey, under the condition that this happened, what's the probability that this thing happens? So I just chose the 5 out of 18. I don't actually have to do the multiplication like I did on that first one. It's very hard to understand. I'm going to do the best I can. I make it as easy as I can because this is not a statistics class where you get into this a bit more. Okay? So let's do replace this time. I would still have the 8 out of 19, but this time it would be 5 out of 19. That's it. Because you replaced it. Is that okay? Okay. This last question I think is a little bit easier to understand. So If you've been confused, you'll be okay. Before I even do it, I'm going to want totals. Total here and a total here. Like this. So I want a total horizontally. Let's probably read the question first. The table shows how Mr. Diaz's class fared on their first driving test. Some took a class while others did not. Find each probability. When they say took a class, like they took a driver's ed class kind of a thing. Okay. So I want to see how many kids passed, whether they took the test or not, or class or not, excuse me. And I want to see failed, whether they took the class or not. So we're going to do a total going horizontally. What's my total for passed? How many kids passed? 112. You're adding 64 and 48. Okay? What about failed? 18 and 32 is 50. Very good. Now I'm going to do totals vertically. How many kids took a class? 82. How many did not? 80. Is anybody confused? Okay, good, because we haven't really done anything yet, right? Part A, find the probability Paige passed given she took a class. This is, again, that conditional probability. Find the probability she passed given she took a class. So the people who passed and took a class is right here. Do you see what I'm saying? Those people passed and took a class. So the probability that she's one of them is 64 out of, and here's how you find the total, okay? She passed given she took a class. How many kids took a class? And yeah, 82. Good. So it's the 64 out of the 82. So reduce that. Those are both divisible by 2. What do you get? 32 out of 41. Is that okay? All right. Let's do probability Madison failed given she did not take a class. How many people failed that did not take a class? 32, right? Out of what do you think the total would be there? 80. Very good. 32 out of 80. And then reduce that. Yeah, 2/5. Good. Are you guys following this one? I feel like these are easier to understand personally. Find the probability Jamal did not take a class given he passed. So what's the numerator here? 48 given he passed out of 112. Very good. Reduce that. 3/7. Excellent. I have an extra question I want to add on the back. So do you guys have any questions before we go there? Are you sure? Okay. I don't know if you need it or not, but it can't hurt to have an extra question. All right, so extra question. Example 1, whatever. 3 marbles drawn from a bag. Is it the same question we just had? I don't know. Drawn from a bag with 8 blue, 7 red, and 5 green without replacement. Okay? Part A, I want you to find the probability of 3 blue. We'll start there. So 3 marbles are drawn from a bag with 8 blue, 7 red, 5 green without replacement. That matters. Okay? Find the probability that we get 3 blue marbles. That means 3 blue marbles in a row. What's the probability that the first one is blue? 8 out of, no, this is 8, 7, and 5. What's it out of? 20, right? Times, the next one being blue. If I'm not replacing them, what is the probability of the next one being blue? 7 out of 19, and another one, 6 out of 18. Do you guys get that? Okay, and then you punch that in. And what do you get? Yep, good. 14 out of 285. Excellent. We'll do one more. Find the probability blue, then green, then red. I have the word then on them. That probably matters. Okay. What's the probability that we start off with a blue one? 8 out of 20 again. Then green. 5 out of 19. Then red, 7 out of 18. Very good. And what do you get? Very good. 7 out of 171. Does anyone need me to go back and say something differently? Again, I know some of these can be really hard to understand when they use the word and when they say the word given or whatever. So if you need help, let me know. But that's why I give you the answers. I think I have the work on here too, just so you understand where it came from. Okay? All right.